The deployment failed. You know it failed because the CloudFormation console says rollback in progress, or the Terraform apply stopped partway through with an error, or the pipeline reported a timeout and the resources that were supposed to be there aren't responding. The obvious move is to clean up and try again. Delete what was created, start from a known good state, fix whatever caused the failure, and redeploy. This feels like the correct response because it mirrors how you'd think about any other failed operation. If something didn't complete, you undo it and retry. The problem is that provisioning failures don't leave you in a state where undo means anything coherent. They leave you in a partial state, some resources created, some not, some created but not fully configured, some created by a process that your tooling doesn't know about, and the cleanup operation you're about to run has no reliable information about what the world actually looks like right now. This video is about what happens when you treat provisioning cleanup as the simple inverse of provisioning, and why the engineers who have done this correctly are the ones who stopped and took inventory before deleting anything. Start with the first assumption built into every instinctive cleanup response that you know what was created. You don't. A failed provisioning operation leaves the world in a partial state, and the degree of partiality depends on exactly when and where the failure occurred, information that the error message often doesn't include with enough precision for you to reconstruct the full list of what exists. CloudFormation will show you which resources are in create complete versus create fad, but resources that were in the middle of being created when the stack rolled back may show as create fad even though they partially exist. Terraform's state file reflects what Terraform successfully recorded, not what the cloud actually provisioned before the error, and those two things diverge precisely during the kind of partial failure you're trying to recover from. The consequence is that when you run Terraform, destroy or delete a CloudFormation stack, you're destroying what the tooling thinks was created. The gap between what the tooling thinks and what the cloud actually contains is the gap where your orphaned resources live. These are resources that exist, are accruing cost, may have security groups open to the internet, may have IAM roles with broad permissions, and your cleanup operation will leave every single one of them untouched because it doesn't know they're there. The second assumption is that deletion is simpler than creation. It isn't. It has the same dependency graph as creation, but traversed in reverse, and the graph becomes harder to traverse in reverse because partial states break the assumptions that deletion relies on. Here's a concrete example. An EKS cluster provisioning fails halfway through. The VPC exists, the subnets exist, the IAM roles exist, the cluster itself is in a failed state, the node groups haven't been created yet. You try to delete the cluster. The deletion requires removing the associated load balancers that the cluster created during its initialization, but those load balancers were created by Kubernetes, not by Terraform, so Terraform doesn't know they exist. The deletion hangs because it can't delete a VPC that has network interfaces still attached to load balancers that no IAC tool is tracking. You can't force delete the VPC. You can't delete the load balancers without finding them manually, because nothing in your tooling tells you they're there. You spend 2 hours in the AWS console finding the dangling network interfaces and tracing them back to the load balancers that the cluster created before it failed. This pattern, resources created by a service during its initialization that fall outside the IAC state, is one of the most common sources of cleanup hangs. EKS creates load balancers. RDS creates security groups. Lambda functions inside VPCs create network interfaces that persist after the function is deleted. CloudFormation stacks that include S3 buckets can't delete those buckets if they contain objects, and the stack that created the bucket may have run code that put objects in it before failing. The IAC tooling cannot delete what it doesn't track. The cleanup you think you're running is the cleanup of the resources your tooling knows about. The resources it doesn't know about stay. The third assumption is that running destroy after a failed apply is safe. This is the most dangerous one, because it feels the most obviously correct. Of course you should clean up a failed deployment before retrying. The problem is sequencing. When Terraform apply fails partway through, the state file reflects a mixed view of the world. Some resources that were successfully created and recorded, some that were attempted and failed before they could be recorded, and some that the apply never reached. If you run Terraform destroy immediately after a failed apply, Terraform will destroy the resources in its state file, which may include resources from a previous successful deployment that the failed apply was updating, not replacing. The failed apply was layered on top of an existing environment. Terraform Destroy will remove the entire environment, not just the failed changes. This is how a failed apply to add a CloudWatch alarm ends up destroying the RDS database that was provisioned 6 months ago and has live data in it. The destroy command doesn't know that the apply was additive, it knows the current state, and the current state includes everything. So here's the mental model that changes how you approach provisioning recovery. Cleanup is not the inverse of provisioning. It is a second provisioning operation, one that runs on incomplete information, on a system that is in an unknown partial state, with the same dependency constraints that govern creation, but without the clean starting point that made the original provisioning tractable. The steps that make cleanup safe are the same steps that make any provisioning operation safe. Establish what state the world is actually in before you start modifying it. In practice, this means 4 things, in this order. The first is inventory before any deletion. Before you run Terraform Destroy, before you delete a CloudFormation stack, open the AWS console and check what actually exists in the affected regions and accounts. Cross-reference against your state file. Look specifically for resources created by services during their initialization, load balancers, network interfaces, security groups, IAM roles that your IAC tooling wouldn't track directly. The resources that will cause your cleanup to hang or leave orphans are precisely the ones that don't appear in Terraform state list. The second is respecting deletion order. Resources must be deleted in the reverse of the order they were created, for the same dependency reasons that govern creation. If your cleanup skips straight to deleting the VPC because that's what the error pointed to, and the subnets and route tables and network interfaces still exist inside it, AWS will refuse the deletion and you'll be debugging the wrong level. Work from the leaves of the dependency graph inward to the root. Leaf resources first, the ones that nothing else depends on. Root resources last, after everything that references them is gone. The third is checking for resources outside your state. After the inventory, and after the IAC-managed cleanup is complete, do a second sweep. Search by tag if your resources are consistently tagged. Use AWS config to find resources that were created in the window when the failed deployment was running. Orphaned NAT gateways and elastic IPs have a cost that accumulates indefinitely at a fixed hourly rate. Orphaned security groups with permissive inbound rules are an open attack surface. Orphaned IAM roles with broad policies are a privilege escalation path. These don't announce themselves. The absence of a resource in your Terraform state is not evidence that the resource doesn't exist. The fourth is treating cleanup as idempotent before you retry the deployment. The test is, if you ran cleanup twice, would the second run do anything? If the answer is yes, if there are resources that the first cleanup left in place, then the cleanup is incomplete, and retrying the deployment on top of incomplete cleanup will produce the same partial failure with compounding complexity. The mental model to keep from this video is this. The hardest part of a failed provisioning is not fixing the failure. It's knowing what the world looks like after the failure before you start changing it again. Every engineer who has run Terraform Destroy on a partially failed environment and lost data they didn't expect to lose, or ran it and watched it hang for 2 hours on a load balancer nobody knew about, was operating on the assumption that cleanup is simple. It isn't. It requires the same discipline as provisioning. Inventory first, dependency order, know what you're touching before you touch it, and it requires it under worse conditions, because the system you're cleaning up is already in an inconsistent state.